Alright guys, so we're starting section 2.2. This is over the shortcut methods for finding derivatives of functions. So we're going to start with this function here. This is just our constant function. This would be a function like y equals 2, y equals 7, y equals -3. If you think about any of those functions, y equals 2 would just be a horizontal line up 2 units, another horizontal line up 7 units. What then would be the derivative of a constant? Thinking that the constant tells us the slope of the function. What is it? I hear some people whispering it. 0, right? The slope of any constant is going to be 0. See, let's take this function here, this y equals -3. If I were to graph it, like I said, it's a horizontal line. The slope of that horizontal line is always going to be 0. So that's why the slope of a constant, the slope of 2, the slope of 7, the slope of -3, all those functions, those values are going to have a derivative of 0. Now let's take a function like this. This would be like if we had y equals 2x or y equals 4x. What's the slope of this? Y equals 2x. 2. What's the slope of y equals 4x? 4. So what's the slope of y equals kx? K. So this derivative is always just going to be k. This is the one I told you to look at the warm-ups for, and we came up with this formula together. We said that if we want to find the derivative of kx to the n, that derivative is going to be k times n x to the n minus 1. The derivative of sine x. This is one that's not quite as intuitive, so let's look at the sine function. So if I go under y equals, and I'm going to graph 3 sine x. I already have my calculator set up so that now it's going to graph the derivative of sine x. So I'm going to go ahead and graph it with a zoom trig. And you can just kind of watch. You don't have to necessarily graph this. Here's 3 sine x. Now it's going to graph the derivative function. So this is the derivative function. So we need to figure out what this function is. So if we look at what this function is, this function, my original function was going 0, 3, 0, -3, 0. The derivative function is going 3, 0, -3, 0, 3. What is that derivative function then? Cosine, isn't it? So the derivative of k sine x is going to be k cosine x. All right, now we want to figure out what's the derivative of cosine. So I'm going to change my sine to cosine. So here's my cosine graph. Its key points are 3, 0, -3, 0, 3. And then here comes the derivative function. Remember the derivative, it takes it a while to calculate it because it's saying, what's the slope right there? The slope's 0, graph it. What's the slope right there? The slope's 3, graph it. So here's our derivative function in red. These key points are 0, -3, 0, 3, 0. What's that function then? It's not exactly 3 sine x though, because it's going 0, -3, 0, 3. Negative, yes. So the derivative of k cosine x is negative k sine x. Okay? So sine and cosine have their own special derivative rules. We cannot use this one right here. This one only works if we have something where we have a coefficient, then an x, then an exponent. So let's try some of these problems now with our shortcut methods. With our old method, we would have had to found the limit as delta x approaches 0 and done all that. Not anymore. To find this derivative, I look at the first term. This is kx to the n. So I have to do k times n. That's 9. X, I have to subtract 1. Now I go to my next term. This is just kx. What's the derivative of kx? It's k, right? So this derivative is just going to be what? 4. And then I go to my next term. This is a constant. What's the derivative of a constant? 0. And so this would be my derivative. Okay? For number 2, I have to think about how I can rewrite this to have it in kx to the n form. Well, the rewrite that would be 1x to the, If I want to take this to the numerator, what's it going to be raised to now? -6. So now to find my derivative, I'm going to have to do k times n, x, subtract 1. But now I want to rewrite this so that I don't have any negative exponents. Remember, to have something simplified, we should not have negative exponents. So now I'm going to have y prime equals -6 over x to the 7th. And that's the derivative. Okay, number 3. Let's work on this. So we're finding this derivative. We've got kx to the n, so we're going to have to do k times n, 15x subtract 1. On this one, we have to do 2 times -2, that's -4, x subtract 1. And then a rewrite on this is 7 over x. How can I rewrite it so I have it in kx to the n? Right, 7x to the -1st. So now I do 7 times -1, that's -7, x subtract 1. Okay. And now I have to rewrite it so that I don't have any negative exponents. And there would be our final answer. Sometimes you check in the back of the book and they might have a common denominator on this, but I think for now they just leave it in this kind of form, but later we might have to get a common denominator or something. Okay, what about radicals? Well, again, I have to rewrite my problem so that this is written in kx to the n form. Does anyone know what the cube root of x would be if I wanted it x raised to a power? 1/3, good. Now, don't take this derivative yet. Here's what I see people do. They rewrite this one, but they take the derivative of that one. Don't do that. We have not taken any derivatives yet, so don't take any derivatives yet. Now we're going to start taking derivatives. So this derivative is going to be 1 times 1/3 is 1/3. X, what's 1/3 minus 1? -2/3. And then over here's 8 times 2 is 16, x subtract 1. And now I want to rewrite it so that I don't have any negative exponents. So I always want you to check your answers. When you check this answer, you may not see it written this way. It might be written as 1/3 cube root of x squared. Do you understand why that would be equivalent? The bottom number here is always your root. The top is your power. Sometimes people forget that. I always think roots are down in the ground, so they're lower. Power lines are up in the air, so they're higher. I don't know, just a little something to help you remember those rational exponents. All right, let's take a look at number 5. This is just another way of saying take the derivative. See, when you first look at this kind of stuff, you're like, what does that mean, right? But when you think about it, it's just another way of saying take the derivative of this function. All right, so my original function then is 2x. How would I rewrite this? 2x to the what? What is it? -1/3. Because I got to take it to the top and write it as a rational exponent. And so now taking that derivative, I just called it y instead. 2 times -1/3 is -2/3. X subtract 1 is -4/3. Look back up at the derivative of k cosine x. The derivative of k cosine x is -k sine x. So this is going to be -3 sine x. Notice how I used my power rule here. The power rule says I do k times n x to the n minus 1. But this has its own special formula. And now I have to rewrite this. This is going to be -2 over 3x to the 4/3. But also recognize it could be written as -2 over 3 cube root of x to the 4th How could I write that? Cube root of x to the fourth. Couldn't I really take an x out and leave one x in? See what I mean? So an even better answer might be negative 2 over 3x cube root x minus 3 sine x. Now, I'm fine if you leave these like this in rational exponent form, but I will, on a lot of quizzes and tests, give you multiple choice. If this is the correct answer, I wouldn't give you this as one of the choices if I really wanted you to write it in radical form. I might give you, like, change these to plus and give that as an option, just to see if you're paying attention. But then this would be, in my opinion, the best answer. The reason I say that's the best answer is because this is starting off with radicals rather than rational exponents, so therefore we want our answer to match the way the original problem's written. That's kind of the general rule on that. Okay? But like I said, when you check in the back of the book, it may have this or it may have it written that way. The other nice thing about calculus is we never have to rationalize the denominator. You know how you spend all that time in Algebra 2 doing that? Then you get into upper level math and they're like, don't worry about it. So, yeah, that's kind of nice too. Okay, guys, that's it for today. You've got your assignment on the board. You can get started.